and welcome to the lecture on Ransac. Ransac stands for Random Sample Consensus, and according to Wikipedia, the definition of Ransac, it's used to detect outliers. We'll see an example of that. If you go to scikit-image, here is an example on Ransac. So we'll look at a similar example. We'll use some of these methods for our example. So what you have here is you have data points here, the red dots, the scattered red points are data sets. Here you have majority of the data set, and the method used here has introduced some noise to our data so that we have outliers. Here you see a bunch of outliers towards the bottom of the x-axis, and you see the black line here. It's kind of a fit line of all data points, and it kind of inclines towards the bottom. That's because it's pulled by these outliers. And the one in blue is the best line fit model. That's by using the Ransac algorithm. That's what we'll see in this example, in this lecture. Okay, so this is the best line, and that involves using Ransac and a linear model that we'll see in this lecture. Okay, so for this example, we'll create a NumPy array and then introduce some noise to our data set and try to build a best line fit by using the Ransac method. Okay, let's start that. So as usual, we import pandas, NumPy, scikit-image, we have matplotlib. I copied this from one of our previous lectures, and we also need to import Ransac. Let's do that too. From skimage.measure, let's import Ransac. Now let's create some data set. We'll use NumPy's arrange method to create an array, and let's create an array between -300 and 300. And for our y-axis, we'll use the line equation y is equal to mx plus c or plus b. Let's say 0.5 times x plus 50, and we'll use NumPy's column stack method and pass our x and y data, and we'll save our data in a variable called data. So np dot column stack, and then pass x and y. What we'll do next is add some more data points so that our data points are random, and let's save that in a variable called data underscore faulty for faulty data. np.array, then we'll take some data points, some range of data point, and multiply it by 40. Let's pass 200, and then make a -130. You don't necessarily need to know all the steps. We're just using this to create, some data points for our Ransac method. And then we'll take our faulty data and then add some values to it. So plus equal 4, and then we'll multiply this by the shape of our faulty data. Okay, so np.random.normal, and then we'll pass the size attribute and set it to be equal to our faulty data faulty.shape. Then we'll take the first index of our faulty data and save it in the same variable faulty data. We'll take data, faulty.shape, and pass 0. Here it's data underscore faulty. What we'll do next is add some noise to our data set, and we'll save that in a variable called data noise. So np.random.normal, and then let's pass size and set it to be equal to the shape of our data that we define at the beginning. And we'll set our data to be equal to our data noise multiplied by some number plus the data itself. So plus equal, let's say 2 times our data noise, and then let's index our data, say up to 2, and then introduce some noise to it using the same method here. So we'll add our data up to index 2 multiplied by some noise. So we'll set that to be equal to plus equal, let's say 3 times our data noise index up to 2. Let's add some more noise. This time let's index it up to 5, and let's multiply this by some other random number 15 times data noise, and that will be up to index 5. Don't worry about the details of all these methods, it's just to come up with some data points. Okay, and now that we have our data points, we can use the plot method and then plot our data. Okay, simply pass your x and y. So we'll pass our index data for x and y, let's say from 0 to 1, and we want to use scatter point, so we'll pass a dot here, and let's see what we have here. Okay, this looks like a nice perfect line of our data points. So what we'll do is we'll introduce some randomness by calling numpy's random seed method. So let me do that, np.random.seed, and we'll set the seed to be equal to 1. Okay, let's run it again. Okay, our data sets still don't look random, so what I'll do next is change some of this values so that we can have more noise in our data set. Okay, so let's try this. I change this to 150 instead of 15. Let me run it again. Okay, now it's more random, so we have more random points here. What we can do next is find a best fit line. So if you look at the example here, you can use the least square method to find a best fit line for all of the data points. I'm not going to do that, but just wanted to let you know that you can use the least square method to find a fit line for all of your data points, and this best fit line using the best fit method is it goes a little bit towards the x-axis because it's pulled by this outliers. That's why it's a little bit down from your robust best fit line. Okay, what we'll do next is find a best fit line using the Ransac method. So for that, we'll be using a model known as an n-dimensional model. Okay, so scikit-image has a model known as the n-dimensional line model, and that will help us find the best fit line. So for that, we'll first import the n-dimensional line model from scikit-image, and then we'll construct our model, and we'll use the data that we defined earlier to find our line model. We'll estimate by our line model by using this data, and then there is a method known as params for parameters. So we'll use that method to find out the parameters, and we'll pass those parameters for our best fit line. Okay, that's what we'll do next. Let's check it out. So let's first import our n-dimensional line model from scikit-image. So from skimage, that measure. Let's import n-dimensional line model nd, and I think we have imported Ransac at the beginning. Yeah, so we have imported Ransac, so no need to import Ransac. So we'll first construct our model by calling the line model method, so n-dimensional line model, and then let's save this in a variable called nd_model. Next, we'll estimate our line model by passing the data we defined at the beginning. So we'll take our n-dimensional model and then call the estimate method and then pass our data. And finally, we'll call the params method. So nd_model.params. So this will give us the origin for our best line fit. Okay, let's run this. So here we have an array. We have two arrays, right? The first one will be our origin, and this will represent the direction for our line. Okay, so we can say model.params, and we'll set the values for this two for origin and then direction. So origin and then direction will be equal to our model.params. So the first array will be equal to our origin, and then the second array will be our direction. Now we can call the plot method, plt.plot, and then pass your x and y values. Okay, so we'll simply pass our x and y values. I'll copy it from here, copy it, and then paste it here. So this will be for our points, and then we'll call the plot method again, and that will be for your line. And so here for our data set, we used from -300 to +300, right? So we want our line to be a little longer than the points so that we can see it. For that, I'll use numpy's arrange method to create an array, and then we'll use that for our line. So np.arrange, and let's pass between -500 and 500. So our line will span from -500 to 500. And let's save it in a variable called x1. Okay, so now that we have that, I'll pass x1 here, and then our n-dimensional line model has a method known as predict_y, predict_y, and we'll use that to draw our best fit line. Okay, so let's do that. nd_model, we defined that earlier. We'll call the predict_y method and then pass our x1 that we defined, and let's use a red line. Let's close our parentheses. So this method basically will predict the values of y from the given x values. Okay, this is our nd_model. Run it again. So here we have a line by using our n-dimensional line model. What we'll do next is use the Ransac method and then pass and then find out the best fit line. Okay, for that, so I'll be using this to save some time. I'll copy this and then paste it and show you and explain what the Ransac algorithm does. Okay, so I have copied the method and then modified it a little bit, and let me explain what this does. So here we have our model robust and in layers, and we have our Ransac algorithm. So what this algorithm does is it will fit the best line by taking our data and using the n-dimensional line model. And for minimum samples, it will take 2 samples, and we have a residual threshold of 10 pixels with maximum trials of 1500. So what does this mean? What the Ransac algorithm does is it will take 2 points randomly, since we said the minimum samples is 2, it will take 2 points randomly. And that's what we need to have a line, right? If we have 2 points, we can have a line. So we have 2 random points, and then we'll have a line, and then it will see how many points are close to your line based on the residual threshold that you pass. So you have a line between 2 points, and then it will see how many points are close to the line. That's 10 pixels. So how many points are within 10 pixels from your line. Okay, it will calculate that, and then that will be your first trial. For the second trial, it will take 2 other random points, and then it will draw a line, and then it will see how many points are within 10 pixels from your line. Okay, and then it will calculate the number of points. Those are called the inliers. Inliers means close to your line, and that will be based on the pixel distance that we define here, the residual threshold. So it will do that for 1,500 times. So take 2 random points, draw a line, and then calculate or count how many points are within the defined residual threshold. That will be your inliers. And then take 2 other random points once we have a line, see how many points are close to our line, and then finally whichever has the most points close to our line will be the best line fit model. Okay, so that's what the Ransac algorithm does. Okay, those are the attributes it takes: our data, the n-dimensional line model, minimum samples we pass 2, residual threshold of 10 pixels, and maximum trials 1500. And then here we have our outliers and inliers. So outlier basically is the opposite of inliers. So outside of the threshold distance pixels will be outliers. And then we have our predict y method that we defined and saw earlier. And here we'll be plotting it. So let me run this cell and then show you the result. Here it says name XX is not defined. Okay, I just copied this from here, and we used x1 instead of xx. Let's run it again. Oh, we have another xx. Where is that? Oh, here. Let's change this to x1. Run it again, and there you go. So we have our inlier data represented by the red points. Our outlier data is represented by this blue points, and then our robust line model is represented by the green line. Okay, this all makes sense now, right? The Ransac algorithm, it will take 2 random points and then draw this line and count the number of data points that are within the given range of, in this example, 10 pixels. So it will count all those data points and then take a note. Let's say the first line has 20 inliers, then take 2 other random data points, draw a line, and see how many points are within 10 pixels, and then calculate the number of points. So it will do that. It will do a number of trials, which is based on what you define here. And finally, based on which line has the maximum number of inliers, you'll have your best fit line. Okay? That's how the Ransac algorithm works. So what you can do is change those attributes, change the values of, let's say, minimum samples. You can change it to 3, residual threshold within maybe 16 pixels, and then you can change the trial to whatever number of trials that you want and see what results you come up with. Okay, and then compare it to what you have here. Okay, so that's the robust best fit line by using the Ransac algorithm. Okay, again, the Ransac algorithm is used for detecting outliers. So go through the example. I know it's a little bit complicated, but I wanted to show you that we can use the Ransac algorithm to detect outliers, and we saw how we can come up with a robust line model. Don't worry much into the detail of how we introduce some faulty data or noisy data for our dataset. Okay, important points to remember is that we have a n-dimensional line model and Ransac algorithms that will help us come up with best line fit models. And also check out this example on scikit-image. Here they have used the least square method to draw a line that represents all the data points, and we can see that it's pulled a little bit towards the bottom by this outlier data. But when we use the Ransac algorithm, we are able to come up with a best fit line, and that takes into consideration of outliers, you see. And you can check out the documentation here for more details on this Ransac line model estimation. Okay, thank you everyone, and see you at the next lecture.